My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 516. In this lecture, we will try to understand weight feature. The next concept we will discuss is called weight feature. We have taken this concept from a research paper called graph-based features for supervised link prediction, and this is very pretty interesting paper. Just say this paper. It's a pretty interesting paper, and one of the feature that discussed in this paper is called weight feature, and the core idea is very simple. So imagine if I have a vertex. Let me assume this is the paper. Just I request all of you to refer this particular paper. You can download this paper and you can check it out, isn't it? So imagine if I have a vertex UI. Imagine if I have lots of incoming edges. Imagine vertex UI is a celebrity. Imagine UI is a celebrity and there are lots of edges coming into it. Let's assume there are 1 million vertices. Let me assume there are 1 million vertices that are linking into UI. UI means celebrity. This is one type of vertex, isn't it? There is other type of vertex UJ, a normal person like me. Let's assume that this person has about 30 incoming links, 30 people linking into UJ. Now because UI is a celebrity, chances that any two random people, chances that now just we will try to understand about UI. UI is a celebrity. Chances that any two random people here, let me say this one is one random person. This is one random person, another random person, isn't there? Any two random people here know each other is very small. But since UJ is not celebrity, and probably the network is a network of friends. In the case of UJ, the probability that a random person here, the probability that a random person here, the random person here knows a random person here is very likely, isn't it? So if you somehow encode the information that somebody is celebrity or not using just number of vertices linking into it, so there is a weighted feature called W, which is defined for any vertex UI. This is defined for any vertex UI, and it's very simple definition. What is its definition? What it says, just see, this is my formula. W equal to 1 by 1 plus 1 plus mod and square root of mod x, isn't it? What is my x? Isn't it? Just see, I will explain what is x. X is basically, what is x? X is basically set of all vertices linking into UI. As it is linking into UI, just instead of W, let me write it as W of UI. W of UI is same formula. Just instead of writing W, here I am writing W of UI. Why? Because I am saying set of all vertices linking into UI. Therefore, formula is 1 by square root of 1 plus number of elements in the set X. This is one. Just if you think about it, when you compute this, for example, in the case of UI, I am assuming, just let me assume, in the case of UI, number of followers, how many we are assuming? 1 million, isn't it? If it is 1 million, what is the formula? 1 by, if it is 1 million, what is the formula? 1 by 1 plus mod x. Number of elements in the following number of vertices linking into UI is 1 million. 1 by 1 plus 1 million. For example, if a normal person like me, just I am assuming 30 persons are linking into me, isn't it? Let it be UJ. Therefore, what is this value? 1 by, what is this value? 1 by 1 plus number of elements in X means 1 by 1 plus 30. Obviously 1 by 1 plus 1 by under root of 1 plus 30 is much larger than 1 by 1 plus 1 million, isn't it? Because the denominator here, in 1 by under root of 1 plus 30, this under root of 1 plus 30, the denominator is small. The overall value will be larger. Therefore, this value will be larger. These are set of vertices linking into UI. 30 is set of vertices number of vertices linking to UI, isn't it? This is so the same thing I can do it for vertices linking out of UI, isn't it? Earlier we were discussing incoming vertices, now out of UI, isn't it? Imagine a person like this who has lots of outlinks. Imagine there is a person like this who has lots of outlinks. Even just imagine one more person about, just let me say this is UI and let me say it is UJ. UJ is, what about somebody has fewer outlinks? UJ has fewer outlinks. Few links, isn't it? Few outlinks. You can compute the same weight feature W equal to, what is my same weight feature? W equal to 1 by under root of 1 plus number of elements in X. This is very popular feature that is recommended in this research paper. We thought we will experiment with this. So we are played around based on the recommendations in the research paper. We have these fields like weight of I can say, just say these features like weight of incoming. We discussed for incoming edges, isn't it? Just see this one. This is formula 1 by under root of 1 plus this is formula, isn't it? And what is this? These are the features. What are added new set of features? What are these new set of features? Weight of incoming edges, weight of outgoing edges. You can see all these things, isn't it? Weight of incoming edges plus weight of outgoing edges, weight of incoming edges plus weight of outgoing edges, 2 into 8. Just go through this. If you go through this 1 to 6, you have 6 features for every vertex UI. This is feature 1. How many features are there? There is first feature, second feature, third, fourth, isn't it? Fifth and sixth. There are 6 features. Just I request all these features, just study these features and adding new set of features, isn't it? What is this? We will create each of these features for both train and test data points, and we already discussed page ranking for source, page ranking for destination, chord source, chords destination, hubs of source, hubs of destination. Or just go through these topics we discussed in our previous lectures. Just in this particular lecture, try to understand. Just see, for every vertex UI, you have these features, isn't it? Just study these features. I will continue my next lecture in lecture I will continue in lecture number 5 and 7, where I will discuss about modeling, how to modeling. That is one of the important topic. With that particular topic, we can complete this particular case study. Thank you very much.